The earliest known Africans to arrive in Europe, known as the Grimaldi people, migrated there about 40,000 years ago. As African civilization flourished, it passed its knowledge to the Mediterranean world. This period marked the second phase of Africa's contribution to universal civilization, where the values and advancements of Egyptian civilization were transmitted to Greece, and from there to the broader Western world. The Greeks who traveled to Egypt, such as Thales in the 6th century BCE, acquired knowledge that they later adapted and passed down as part of their own intellectual heritage. Africa is often considered a primitive continent that has contributed very little to the progress of civilization. People frequently talk about the rendezvous of giving and receiving, implying that Africa still needs to prove itself, and only in the final stages of universal civilization might it contribute something to humanity. However, this view completely reverses the course of history and tells the story backward. The reality is that it was the African continent that was at the origin of all civilization's development. I would like to highlight 3 key stages of this evolution and discuss them with you. Let's start at the very beginning. Today, it is widely accepted, but this was not always the case. About 30 years ago, suggesting that Africa could truly be the cradle of humanity seemed a far-fetched idea, and it took considerable intellectual courage to propose such a thought. Since then, research has advanced, and we now know that Africa is indeed the birthplace of humanity. You might say that the cradle of humanity has been described as a cradle on wheels, moving from one continent to another. Initially, it was placed in Asia for reasons rooted in biblical tradition and appearances. Asia was seen as the home of the 3 races, black, white, and yellow, and biblical tradition also placed the cradle of humanity there. Early archaeologists like Marcelin Boule and others attempted to verify biblical accuracy by undertaking excavations in Mesopotamia to prove the occurrence of events like the flood. In Asia, they found the Pithecanthropus fossils, which, despite being scant evidence, were enough to claim that the cradle of humanity was in Asia. However, as research intensified, it became apparent that Africa, rather than Asia, should be considered the starting point. This was not a completely new idea, as even Darwin had suggested that humanity might have originated in Africa. Today, the fossils and other archaeological findings in Africa leave no doubt about this. Africa is the cradle of humanity. Once the cradle was placed in Africa, it never left. Every day, new discoveries in prehistory and prehistoric archaeology reinforce the fact that Africa is indeed the birthplace of humanity. 6 specimens of early humans, or proto-humans, were born in Africa. While the term human may not be entirely appropriate for all of them, for the sake of illustration, let's say that 6 types of early humans originated there. The first 3, Australopithecus robustus, Australopithecus gracilis, and Homo habilis, did not, according to current research, have enough expansion potential to leave Africa. However, the other 3 did migrate out of the continent and went on to populate other regions. The 3 that left Africa were Homo erectus, who appeared in Africa around 2 million years ago, Homo neanderthalensis, known as the Neanderthals, and Homo sapiens, the modern human species. These 3 varieties of early humans left Africa to populate the rest of the world. Homo erectus, for instance, likely began leaving Africa around 1.7 million years ago. There were 2 main exit routes, one via the Sinai Peninsula, the Isthmus of Suez, and the other through the Strait of Gibraltar. These routes were utilized by the first humans born in the East African region, encompassing Ethiopia, Kenya, Tanzania, and even as far south as South Africa. This early humanity spread out of Africa through these pathways. The migration of Homo erectus out of Africa occurred probably around 1.7 million years ago. Modern humans, or Homo sapiens sapiens, began leaving Africa about 40,000 years ago, moving into Europe, especially through regions like Spain and France. It is this process of migration and adaptation to different environments that led to the development of various racial groups. If humanity had remained in Africa, the diversity in racial features would likely not have emerged because the African climate did not necessitate extreme physical differentiation. It was as Homo sapiens moved into Europe during the last ice age, which lasted for about 100,000 years, that these physical traits began to change. The challenging environmental conditions in Europe encouraged evolutionary changes, leading to the gradual development of lighter skin over a period of approximately 20,000 years. The first Africans to enter Europe are known as the Grimaldi people, who arrived about 40,000 years ago. They stayed in Europe, evolving until around 20,000 years ago, when the first light-skinned people, known as the Cro-Magnons, appeared. About 15,000 years later, the Chancelad people, considered the prototype of the yellow race, emerged during the early Paleolithic period. These three racial groups, the black, white, and yellow, existed during the last glaciation. The earliest group, the black race, spread from Western Europe to as far as Lake Baikal in present-day Russia, across regions like Crimea and the Don Basin. Archaeological findings suggest that 32,000 years ago, there was a single homogeneous humanity, which was Negroid. As they migrated, they began to differentiate. The same humanity that populated Europe eventually crossed the Bering Strait around 15,000 years ago to populate the Americas. This migration pattern supports the idea of a single origin for all humans because, despite the diverse climates found across the Americas, no earlier human fossils, such as Homo erectus or Australopithecus, have been found there, indicating that only later human species migrated to the Americas. Moving beyond prehistory, we enter the historical period, which is characterized by the advent of writing. Once again, Africa, specifically Egypt, was ahead of the rest of the world. The Nile Valley civilization developed a system of writing as early as the 4th millennium BCE. By 3236 BCE, the Egyptians had already established a sidereal calendar based on the rising of the star Sirius. They recognized that this star rose with the sun every 1,460 years, which became the basis for their timekeeping. Under the Old Kingdom, the Egyptians had already mastered various scientific fields, including medicine, geometry, algebra, mechanics, and architecture. For example, the great scholar Imhotep, later deified by the Greeks, made significant contributions to architecture and technology during the reign of Pharaoh Djoser. Greek scholars who traveled to Egypt, such as Thales, Pythagoras, and Plato, learned from Egyptian science and mathematics. The Greeks later adapted these teachings, but the foundations were undeniably African. Despite often being credited as the originators of Western science, many of the concepts attributed to the Greeks were actually inherited from African civilizations. To sum it up, Africa's contributions to universal civilization are substantial and deeply rooted. The continent not only gave birth to humanity, but also played a crucial role in shaping early human society and scientific knowledge. Understanding these contributions allows us to acknowledge the interconnectedness of human cultures and the central role that Africa has played in the history of civilization. I really want to emphasize these facts about Africa in prehistory. Homo erectus entered Europe around 400,000 years ago, followed by Neanderthals, who probably arrived around 100,000 to 150,000 years ago. Then came Homo sapiens sapiens, modern humans like us, who left Africa about 40,000 years ago and gradually spread across Europe. This is essentially the process of the formation of humanity, from its origins to its migration and settlement on different continents. If humanity had remained confined to Africa, it wouldn't have developed into different races. The African continent has a relatively stable climate that doesn't strongly favor racial differentiation. Hence, race is fundamentally a geographical concept. It was the migration of Homo sapiens sapiens out of Africa 40,000 years ago, particularly into Europe, that led to the process of racial diversification. These early humans entered regions like Spain and France, where they endured extremely harsh conditions during the last Würm glaciation, which lasted about 100,000 years. The specific environmental challenges in Europe drove the evolutionary changes that led to the development of different racial features. The humanity that emerged in Africa around 120,000 years ago, represented by Homo sapiens sapiens, was necessarily Negroid in appearance. For higher organisms to survive in the prehistoric conditions of East Africa, around the latitude of Kenya, they needed to be heavily pigmented to protect against ultraviolet radiation. Melanin functioned as a shield, safeguarding the organism and allowing it to endure. This explains why the early humans born in Africa had darker skin. When these humans migrated to Europe under the different conditions of the prehistoric world, they gradually adapted to the new environment. These adaptations resulted in lighter skin tones over time. This change is estimated to have occurred over a period of approximately 20,000 years. The earliest known Africans to arrive in Europe, known as the Grimaldi people, migrated there about 40,000 years ago. They remained there, evolving until around 20,000 years ago when, for the first time, lighter-skinned humans, known as the Cro-Magnon, appeared. It took another 15,000 years for a different human type to emerge, commonly referred to as the Chancelade man, which is considered a prototype for the so-called yellow race. During the early Paleolithic period, these three main racial groups, black, white, and yellow, existed simultaneously in the context of the worm glaciation. The earliest racial group, the black race, spread from Western Europe across to Lake Baikal, through areas like Crimea and the Don Basin, covering the whole of present-day Europe. Around 32,000 years ago, archaeological evidence shows that there was a single homogeneous humanity of Negroid origin spread across these regions. As they migrated, they also began to differentiate into distinct groups. This same humanity later crossed the Bering Strait around 15,000 years ago to populate the Americas. The settlement of the Americas is a strong confirmation of the monogenic origin of humanity. Despite the wide range of climatic zones in the Americas, from Tierra del Fuego to Alaska, there are no earlier human fossils, such as Homo erectus or Australopithecus, found there. This absence supports the theory that early humans migrated from Africa much later. Homo erectus, for example, did not reach the Americas despite leaving Africa and being found in other parts of the world. Thus, the monogenic theory, which posits a single origin for humanity, has been confirmed by prehistoric archaeology, even though it may have seemed implausible at first. There is also the polycentric theory, which suggests that, under certain conditions, nature could have independently created different human races in various regions. However, this theory is not supported by archaeological evidence, and is unlikely because it is highly improbable for nature to follow the same evolutionary path multiple times. The monogenic theory aligns with the actual process of human evolution and is consistent with scientific findings. By embracing this understanding, we acknowledge that Africa, by sheer chance, became the birthplace of humanity, and the subsequent population of the rest of the world began from this continent. Those who left Africa did not migrate empty-handed. They carried with them the skills and technologies they had developed. For example, the Aurignacian industry, associated with the Grimaldi people, brought sophisticated stone tool technology to Europe. These early humans arrived with well-established cultural and technological practices, which were revolutionary at the time, especially given the challenges of surviving in a largely untamed natural world. As humanity transitioned from prehistory to history, the invention of writing marked the beginning of recorded history. Once again, Africa led the way, with the Nile Valley civilization advancing ahead of others due to several factors. Europe, at that time, was still emerging from the lengthy worm glaciation, which lasted about 100,000 years, ending around 10,000 BCE. During this period, Africa experienced relatively normal climatic cycles, alternating between dry and wet phases, which allowed for more consistent cultural and technological development compared to Europe, where people still lived in caves. As a result, Africa entered the historical period first. By the end of the 4th millennium BCE, Africans had already invented writing. From around 3300 BCE, there are written documents that allow us to trace the evolution of African civilizations, particularly in the Nile Valley. Around 4236 BCE, Africans had already created a sidereal calendar based on the rising of Sirius, the brightest star in the sky, located in the constellation Canis Major. The Egyptians observed that Sirius rose with the sun every 1,460 years, and this phenomenon formed the basis of their calendar. The accuracy of the Egyptian calendar shows the advanced astronomical knowledge of the time. They observed that the star rose simultaneously with the sun at a particular latitude, with this alignment occurring every 1,460 years. This understanding led to a precise system of timekeeping that could account for discrepancies over time. For example, they knew that the annual alignment drifted by about a quarter of a day each year, necessitating adjustments over a 4-year period to maintain accuracy. By the Old Kingdom, around 2778 BCE, during the reign of Pharaoh Djoser, all the essential elements of Egyptian civilization were in place. The Egyptians excelled in various scientific and technological fields, including medicine, mathematics, engineering, and architecture. The famous polymath Imhotep, who was later deified by the Greeks, made significant contributions during this time, especially in architecture, with the construction of the step pyramid. Mathematics in Egypt, particularly geometry, was highly advanced compared to Mesopotamian practices. The Rin Papyrus, for example, contains mathematical problems that illustrate the Egyptians' theoretical knowledge. These were not just practical calculations, but demonstrated a deeper understanding of abstract mathematical principles. The Egyptian influence extended beyond science and into art and architecture. The use of dressed stone in construction began during the Third Dynasty. Egyptian architectural techniques and artistic styles later influenced Greek culture, particularly in the adoption of similar artistic canons. As African civilization flourished, it passed its knowledge to the Mediterranean world. This period marked the second phase of Africa's contribution to universal civilization, where the values and advancements of Egyptian civilization were transmitted to Greece, and from there to the broader Western world. The Greeks who traveled to Egypt, such as Thales in the 6th century BCE, acquired knowledge that they later adapted and passed down as part of their own intellectual heritage. However, it is crucial to acknowledge that much of this knowledge originated in Africa. The exchange of ideas and technologies facilitated by these early scholars helped lay the foundation for Western civilization, but it began with the early achievements of African societies. Africa's role in the history of humanity is not only foundational, but also transformative. From being the birthplace of humanity and the origin of early human migrations, Africa has contributed significantly to the development of science, technology, and culture, laying the groundwork for the progress of civilization worldwide. Imagine the sun, a phenomenon so fleeting, rising at the same time as a star. This event lasts for just a few seconds, less than a minute, and it does not happen again for another 1,460 years. If you observe it over consecutive years, you'll notice that after the first year, there is a discrepancy of a quarter of a day. In the second year, it grows to half a day. And after 4 years, there is a 1-day difference. Consequently, since around 4,236 BCE, the Egyptians were aware of the leap year and could have easily adjusted their 365-day calendar by adding an extra day every 4 years. However, instead of correcting the calendar every 4 years, they chose to observe the phenomenon's shift over 1,460 years before adding an additional year to the calendar. The Egyptians valued this sidereal calendar so highly that the pharaoh established a special office to monitor the time difference between the sidereal calendar and the ordinary calendar. This monitoring was essential for understanding the heliacal risings that marked Egyptian history. This serves to illustrate that Egypt entered the historical period with precise astronomical knowledge. On this point, there is near unanimity among specialists. The Egyptians had mastered a method for determining lunar phases that was completely distinct from the methods that would be invented later. While the Egyptians were able to predict the movement of the heavens from very early times, in Mesopotamia, despite many observations, they never managed to establish a regular or reliable calendar. Mesopotamian astronomy is more accurately described as astrology, as it lacked the systematic precision found in Egyptian astronomical practices. Although many observations were made in Mesopotamia, including relevant ones, they never developed a consistent calendar. For example, to account for discrepancies, they occasionally added a 13th or 14th month, and toward the later periods, they devised various rules to adjust the calendar based on lunar observations. In contrast, during Egypt's Old Kingdom, around 2778 BCE under Pharaoh Djoser, all the technological elements of Egyptian civilization were already in place, including medicine, mathematics, geometry, algebra, trigonometry, mechanics, and architecture. The Egyptians were advanced in these fields during the Third Dynasty. This was the time of Imhotep, a polymath whom the Greeks later deified, who contributed significantly to advancements in architecture and medicine. The Egyptians developed dressed stone architecture during this period, setting the stage for the monumental constructions for which ancient Egypt is renowned. Egyptian mathematics, particularly geometry, was sophisticated and rigorous, unlike the less precise Mesopotamian approach. The Rhind Papyrus, a well-known mathematical text, shows that scribes had copied even older works dating back to the Old Kingdom. The Moscow Papyrus, another important document, contains mathematical problems that demonstrate a high level of abstraction and theoretical understanding, later influencing Greek scholars like Pythagoras, Thales, Plato, Eudoxus, and Archimedes. For example, the Moscow Papyrus includes problems related to calculating the volume of truncated pyramids and spheres. The Egyptians had a precise formula for the volume of a truncated pyramid, which matches the modern equation. 1/3 of the height times the sum of the squares of the top and base sides, plus the product of the top and base sides. Achieving such an analytical expression would not have been possible through empirical observation alone. In contrast, Mesopotamian mathematics offered an incorrect formula for the volume of a truncated pyramid, demonstrating that their geometry was indeed empirical and often inaccurate. Their formula did not include the term necessary for calculating the volume correctly, indicating the limitations of their mathematical approach. The Moscow Papyrus also addresses the volume of spheres. Those with a background in mathematics will understand how challenging it is to derive the surface area or volume of curved shapes. Yet, the Egyptians managed to arrive at the correct formula for the surface area of a sphere, 4 times pi times the square of the radius, which aligns with modern mathematics. This theoretical approach to mathematics further highlights the advanced nature of Egyptian knowledge. Archimedes, often regarded as one of the greatest mathematicians of antiquity, considered his discovery related to spheres and cylinders to be his most significant achievement. The figure representing this discovery was even engraved on his tombstone. Yet the Egyptians had already conceptualized this over 2,000 years before Archimedes was born. These examples show that Egypt's mathematical knowledge was not just practical, but also theoretical. Contrary to claims that Egyptian mathematics was purely empirical, their work contained a level of abstraction and theoretical rigor that would later be transmitted to Greek scholars. The evidence for this transmission of knowledge is well documented, though often underappreciated. Egypt's scientific achievements were not limited to mathematics. They extended to medicine, where evidence from the Edwin Smith Papyrus shows that the Egyptians had a sophisticated understanding of anatomy and surgical practices, including knowledge of the brain and its functions. This text contains the earliest recorded cases, linking brain injuries to physical impairments, indicating a level of medical knowledge far ahead of its time. The Egyptians also excelled in the arts, with the development of dressed stone architecture dating back to the Third Dynasty. Their artistic influence extended to Greek art, particularly in the use of canons of proportion that guided sculpture and painting. The parallels between Egyptian and later Greek art underscore the transmission of cultural and artistic practices from Africa to the Mediterranean. Egypt's civilization, therefore, played a fundamental role in shaping the course of history. The technological and scientific innovations developed in Egypt were transmitted to other cultures, particularly Greece, during a second phase of African influence on global civilization. This process of transmission helped lay the groundwork for the development of Western culture, illustrating Africa's pivotal role in the history of human progress. In conclusion, Egypt's entry into the historical period was marked by significant advancements in various fields of knowledge. many of which formed the foundation of later civilizations. The Egyptians' ability to observe, record, and interpret natural phenomena allowed them to develop complex systems of timekeeping, mathematics, medicine, and the arts. These contributions demonstrate that Africa's role in the history of civilization is not only foundational, but transformative. The knowledge developed in Egypt was not confined to the Nile Valley, but was passed on to subsequent cultures, making Africa a central player in the development of human civilization. Remarkably, the Egyptians had grasped this concept approximately 2,000 years before Archimedes was even born. Today, historical research, based strictly on documents available to humanity, supports this fact. Other scholars are aware of these findings, and some acknowledge them, but these facts often remain confined to academic circles. The purpose of this lecture is to share knowledge that has been known for a long time, but hasn't been popularized. Much of what the Egyptians achieved remains largely in libraries due to the lack of widespread dissemination. In the field of Egyptian arithmetic, they had also developed what could be considered today as a form of logarithmic table. This consisted of decomposing fractions with a numerator of 2 over odd numbers. Such decompositions enabled the Egyptians to perform various arithmetic calculations, suggesting a deep understanding of elementary mathematical theories. Because Egyptian civilization was highly secretive, much of their scientific knowledge was lost or closely guarded, making it difficult even for the Greeks to access. Notable figures such as Pythagoras, Plato, and Eudoxus had to undergo significant challenges to learn these secrets. In 1967, American researchers sought to determine whether Egyptian methods were purely empirical or rational by using computers to analyze ancient mathematical problems. They tested 50 arithmetic equations and found over 22,000 possible decompositions. Despite this, the 1967 computer was unable to outperform a scribe from 4,000 years ago, confirming that the Egyptians employed rational methods. The Egyptians also pioneered trigonometry. Their mathematical texts show mastery of arithmetic and geometric progressions, with exercises addressing complex problems, including systems of first and second degree equations. This indicates their familiarity with algebra. In terms of engineering, evidence suggests the Egyptians used inclined planes to move massive stones for pyramid construction. By measuring the slope of these ramps, it is possible to calculate the amount of force required and estimate the time taken to build structures like the Great Pyramid of Giza, which took around 30 years, and the Pyramid of Sneferu, which took about 19 years, not a century, as sometimes thought. The Egyptians were also highly advanced in medicine. According to Herodotus, their medical specialization included doctors for the eyes, stomach, and other specific areas, as well as general practitioners and healers who focused on psychological therapies, resembling modern psychiatric treatments. The Edwin Smith Papyrus, one of the oldest medical texts, shows that the Egyptians had developed a scientific approach to bone surgery. It also contains the first known references to the brain and attempts to link brain injuries to physical symptoms like paralysis. The Egyptians' scientific achievements extended beyond exact sciences to the arts, with dressed stone architecture dating back to the 3rd dynasty. There is no doubt that Egyptian art influenced Greek art, evident in the use of similar artistic canons. These parallels underscore the transmission of artistic traditions from Egypt to Greece. The second phase of African influence on civilization involved the transmission of Egyptian knowledge to the Mediterranean world, especially Greece. The earliest known Greek to travel to Egypt for study was Thales in the 6th century BCE. The idea that Thales performed surveys and measurements at the Great Pyramid is more legend than fact. It's crucial to understand that at that time, Greece was still relatively undeveloped compared to Egypt. Egyptian science emerged under state protection and developed to serve the state, particularly for managing the environment along the Nile Valley. In contrast, Greek tradition was often resistant to innovation. It's important to remember that even Socrates was executed for supposedly corrupting the morals of the city. Greek society, despite its later contributions, initially struggled with accepting new ideas, whereas scientific and mathematical knowledge in Egypt was deeply ingrained as part of a long-standing African tradition. Overall, Egypt's civilization played a pivotal role in the history of human progress. The technologies and scientific advancements developed there were foundational to later achievements across the Mediterranean and beyond. Socrates died by drinking poison, hemlock, as you know. And this happened because he was suspected of deviating from the moral code of the city and adopting universalist ideas that could undermine the institutional foundations of Greek society. This reflects a kind of northern individualism inherited from the steppes and Asian regions. It was Thales who first went to Egypt, studied Egyptian mathematics, and introduced geometry to Greece. Even during Plato's time, Greece had not moved beyond the city-state framework. In contrast, Egypt, and Africa more broadly, had already established states that encompassed multiple cities, complete with distinct institutions and a different political philosophy. Science was a novelty in Greece, and it faced significant resistance from the religion and traditions of Greek society, which was one of the most intolerant societies of antiquity, until the popular revolutions and the rise of democratic assemblies. Greek social structures were rigid, and any innovators faced fierce repression. Anaxagoras, for example, nearly faced execution, but was saved by his friendship with Pericles. Aristotle also had to flee to avoid being killed, as did Plato. Socrates, however, was executed. This reflects the broader attitude of Greek society towards its intellectuals. There was no room for philosophical or scientific innovation. These ideas were foreign to the Greek social structures until significant changes occurred. The future of Greek society was not driven by its aristocracy, but by the common people, those without property or political rights, who lived outside the city walls. These disenfranchised groups had to fight for the right to participate in society. The real potential for secular and rational thought in Greek society lay with the common people, and it was with their rise that Greek society began to secularize, despite the complex conditions surrounding these changes. This historical context highlights the resistance to innovation and the struggle for new ideas in ancient Greece. Until the lions have their own historians, the tales of the hunt will always glorify the hunter.